Next, we'll see first classic problems of synchronization, that is bounded buffer problem. The bounded buffer problem is related to the producer consumer problem, and there is a pool of n buffers, and each of the buffers are capable of holding one item. And in this, the three shared semaphores are used. One is mutex semaphore, and another one is empty and a full semaphore. All the three are a semaphore variables. Mutex, it provides a mutual exclusion for access to the buffer pool, and it is initialized to 1. Empty semaphore, it counts the number of empty buffers, and full counts the number of full buffers. Empty semaphore is initialized to n, and full semaphore is initialized to 0, because all the buffers, we have got n number of buffers, or initially all the buffers are empty, so empty equal to n. Full, that is none of the buffers are filled with any of the data, so full is a 0. Okay, next, and this is the code of producer process, and this is the code of consumer process. Producer process, if it wants to produce an item into the buffer, then this first code, the producer process code, is executed. If the consumer wants to consume an item from the buffer, then it consumer process code will be executed. Okay, and here the critical section is what? It is a buffer, that is the n number of buffers, or is the critical section. While the producer process producing an item into the buffer, the consumer is not allowed to consume an item from the buffer. That is called as mutual exclusion, and that is provided with the semaphore variable mutex, and it is initialized to 1. Now I will see the producer process code. Okay, suppose assume that the producer wants to produce an item into the buffer. In that case, it performs a wait operation on empty, because the producer is going to place an item into the buffer. The empty semaphore should be decremented by 1, because one of the buffer is filled by producer process. So before placing an item into the buffer, okay, empty semaphore should be decremented by 1, and that is done by performing wait operation on empty semaphore. Then after performing an wait operation on an empty, what is the wait operation? It just decrements the semaphore variable. Here the semaphore is empty semaphore. Once the wait operation is performed on an empty semaphore, its value is decremented by 1, and it checks this condition. What is the value of the semaphore here? Empty semaphore, it is n. It is decremented by 1. It becomes n minus 1. It is not less than 0 if condition fails, and it comes out of this wait operation. Next, again it performs, before entering into the critical section producer process, again it performs wait operation on an mutex. Okay, mutex value is initially it is 1. Once it performs wait operation on an mutex semaphore value is decremented by 1. It becomes 0. Again it checks the condition whether it is less than 0. It is not less than 0, and it comes out of the wait operation on mutex semaphore, and then it is able to produce an item into the buffer after executing its critical section part. In this case, producing an item into the buffer, it signals on an mutex. Once a signal operation is performed on a mutex, again the mutex value is incremented by 1. That is the definition of signal operation. If it performs a signal operation on any of a semaphore value, semaphore value is incremented by 1.